What is up, Five Keys? Mr. Mike here. It is February 9th, 2022. It's not morning time. It's like 1:10 p.m. It's almost nap time for me. So as if I'm not goofy enough, today might be really interesting. I don't even know what we're doing. Just kidding. We're on module 4 in Introduction to Functions. Lesson 1, which is using graphs to relate to quantities. Well, this might be fun. It actually is going to be super exciting because we've been module 3 was all about thinking of was all about inequalities, right? But what inequalities does to the way we're thinking about algebra is we go from, hey, let's solve for x, which is a finite number. So really, by finite, I mean it is a number. It's 3, it's 10, it's 1.2, whatever it is. But as we moved into module 3, it became about x as a set of answers or a domain or a range of answers, a whole bunch of different things in a row, right? There were inequalities. So x was everything that was greater than 5 or everything that was less than 2. And now we're going to start relating things. So x is not so much a number or even a set of numbers, but x is something like time. Or x is something like, I don't know, the cost of milk, and it's truly a variable. It's truly something that varies. And the best and oftentimes the only way to really represent it is algebraically with the numbers or graphically on an XY coordinate system. So we're going to see single coordinate graph, not the scale. Okay, we're going to see what that looks like. Let me show you what I'm talking about here. So where we've been used to seeing number lines where we would put a number down, now we're going to see a horizontal number line, and then we're going to overlay a vertical number line on it also, so we can relate to things. So for instance, let's say we're trying to relate the time and where we are in space if we're driving to Big Bear or something. So in hour 3, or I guess it doesn't take that long to get to Big Bear, but at hour, I'm in LA. At hour 3, we are 20 miles out. Let's pretend that we're walking. We're 20 miles out, so we are here. Right now, x is the horizontal component of this. That's crazy, right? I don't even know what that means. Well, we're going to break it down over the course of this module and have a really great sense of what algebra is all about when we start to think of it as functions and relating to things versus simply solving for x or solving for whatever. All right, so let's pull up our lesson and see how deep of a dive we have to do in the first lesson. I don't want to make a copy. I shouldn't show you guys how to do this. Chaos will ensue. But always make a copy when you're working on these Google Docs. Otherwise, it will mess everything up. It'll usually prompt you to make a copy, so you don't have to worry about it. But there is a workaround. Okay, using graphs to relate to quantities. A quantity is a number, and generally we refer to quantity, which I don't know what the Spanish word is. In Italian, it's quando. It's like how much, right? In English, it's how. It's related to the word quantity somehow. So here we go. In this lesson, you will represent mathematical relationships using graphs. I told you I was tired today. Did you know you can use a visual model, a graph, to represent the relationship between two variable quantities as they change? So that's a really confusing sentence, but I think down below the image is a little bit more clear. The graph on the right shows the volume of air in a balloon over time. Okay. This is funky. This horizontal line here, the line that goes from left to right, is an axis. Oftentimes the x variable will represent that when we're writing out equations. We don't think of time as being related to space, really, unless you're super into physics, and then you might. But time when we're looking at it mathematically, oftentimes we will represent it as a line. So it starts at 0 and it goes to 2 hours, and we think of that as having space. So this balloon, while it looks like it's moving from left to right, it's not. This is time. This is time. This balloon is not moving at all because the axis on the y is its volume, and we may want to think of volume as its size, right? So what's happening here? Well, they're blowing up the balloon. They're blowing up the balloon. It's getting bigger and bigger, 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 bigger. What's happening at these little spaces here? Well, whoever's blowing up the balloon may be taking an inhale. So then what happened? It popped. Oh my gosh. And it went from being kind of full to having 0 volume like that because it popped. Poor Mr. Balloon. What do you think happened to cause a vertical line drop on the graph? Well, I just gave it away. I didn't even know that was going to be the question. Silly teacher. The graph, let's do a quick review. The graph is created in a Cartesian coordinate system, which consists of intersecting number lines. That is, golly gee, gosh darn it, I should have kept up that thing. I'll get started. No, I just want the single quadrant graph paper, let's go. Okay, so this is a Cartesian graph. This is quadrant 1. There is a quadrant 2 to the left of here that's not represented, a quadrant 3 to the left and down, and a quadrant 4 down. So this is quadrant 1. It represents all the positive numbers. And it's called a Cartesian coordinate system. I don't know why it's called the Cartesian coordinate system. I don't know who Cartesian was. Armenian, maybe? Could have been. Sounds like an Armenian name or a Greek name. The x-axis is the scaled horizontal number line. There you go. The y-axis is the scaled vertical number line. This is important. The point where the two axes, plural of axis, intersect is the origin. So you hear that term quite a bit. This is the origin. This is the origin. The axes divide the plane into 4 parts called quadrants, which are numbered from 1 to 4 in Roman numerals. So we're going to learn more about these parentheses and these commas in a second. Just know that in quadrant 1, which is what we generally work with, the x-axis is positive and the y-axis is positive, positive, positive. We generally list the x first. Positive x, positive y. In quadrant 2, we're in the negatives for the x. We're to the left of 0 for the x, but our y is still positive, right? We're above 0. This is like a thermostat. This is the number line we've been working with. Quadrant 3, we're negative, negative. Both our x and our y's are negative. Quadrant 4, the x's, the first number, are positive, and the y's are negative. We're down below 0, but we're to the right of 0 horizontally. The location of the points in the Cartesian coordinate system are written as ordered pairs. Those are points, x, comma, y, with the x coordinate followed by the y coordinate, similar to the game Battleship. That's an antiquated reference. In the point on the right, the point 2, 3 is 2 units to the right from 0, and then 3 units up from there. Okay, so if this is new to you, if this is a review and you're like, oh, I got that, great. If this is new to you, this is an incredibly important concept, how these ordered pairs look. So this is the point right here, 2, 3. Okay, this black dot. here's my origin. I am 1, 2 away from the origin, horizontally, left to right. That's why that first number there is a 2. Vertically, I'm 1, darn it, 2, 3 from the origin, 0, 0. That's why this number here is a 3. My x is a 2, 1, 2. My y is a 3, 1, 2, 3. Okay, this is a really important point and important point. No pun intended. Okay, so example, what are the variables in the graph below? How are the variables related at different points on the graph? So the variables are time, board length. I don't understand what that means. Time, and then is 0 is the horizontal, length is the vertical. It's very, very, very common for the horizontal to be labeled as time and to represent time, but it's not always going to represent time. It has to be clearly stated. At different intervals of time, the board is getting shorter and shorter, then stays at a certain length, possibly being cut to fit a structure. I don't get it. So here's, you try. Okay. What variables in the graph above? Okay, well, what's my x's, my horizontal? They're minutes of calls, presumably on a cell phone bill, of calls on the cell phone. And then my vertical, I'm just going to call it vertical, is the cost of my bill. Okay, how are the variables related at different points on the graph? All right, well, I'm going to say it looks like I paid a certain amount for a set number of minutes, right? Because I bought into the plan here. It doesn't give me a number, so I don't know how much I paid, but it's not 0, it's more than 0. And that cost didn't change, right? So I just paid my $100, whatever it was. And then right here, oh my gosh, all of a sudden it starts to go up as I'm talking, right? As my minutes of call move forward. I pay a certain amount for a set number of minutes. And when I went over those minutes, the costs went up for every moment I was talking, or I used the phone. I don't know, something like that. So you should be answering these on your own words, by the way. Matching a table and a graph. A band allowed fans to download its new video from its website. That was nice of them. The table shows a total number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data shown in the table? Okay. So day 1, about 346. Day 2, about 1,011. Did it go up evenly? So if they had 346 on day 1, how many did they get on day 2? It says total downloads. So the 346 is included in this 1,011. So if I take it away, it's about 600 something, right? 670 maybe. And then they got like 2,000 more. And then they got like 7,000 more. Oh my gosh, on day 4. So this shows a pretty even increase, right? Like it looks like on day 1, it got, let's say 1. That looks about maybe the same, maybe even a little bit less, maybe a half, a half, a half. So man, that's not quite right. Well, it didn't get less, which is what's going on here, right? That vertical distance is decreasing every day. This one's going down. So if they got 100 on day 1, they only got 90 on day 2. 80, 70, but this one, oh, okay, they got more and more every single day. That's important to note. Okay, so I'm gonna go with B here. Let's discuss. I think we just did that. The best answer is B. I totally agree. Goodness gracious, Charlie Brown. The table shows the amount of sunscreen left in a can based on the number of times the sunscreen has been used. So number of uses, amount of sunscreen left. So it looks like as there's 5 ounces when it hasn't been used at all. When they bought it, they used it once. It looks like they used 0.2 ounces. Twice, they're using 0.2 ounces at every turn. So here this is 1, 2, 3. This one suggests that it's going down at each turn, but it is at the end, they're at 0. So they used it all on part A, and that's not true of our graph here, because by the third number of use, they still have a whole lot left in here. In B, it doesn't look like they're using it evenly. It looks like each time they use it, they use a whole lot more because it's dropping increasingly dramatically. So it's not B, but C looks like a good choice. It's a nice steady decline, and there's still a lot left at 3. Okay. Which graph could represent the data shown in the table? Explain your answer. I'm gonna let you do it. I just talked it out. You got this. You got this. There is no wrong answer. I promise. Just do your best. I've lost my, there we go. Shoot, I also made a mistake. I'm going to delete this because sorry, stay with me. Don't go, stay with me. I'm just going to delete these because I'm working off the original and I don't want to give away the answers to everyone doing it. Okay. We're going to skip. Let's do the you try. So this is kind of interesting. Height and time, model rocket flight. So this is time, remember. So this rocket isn't moving horizontally. This rocket's moving straight up. It rises quickly. It stops rising. It falls quickly. Its parachute opens, and then it falls really slowly. If you can see my mouse to the right over here. Okay. So if you visualize this, don't visualize. I gotta stop sharing for a second so you can see me. If you visualize that graph, don't visualize the rocket as going like this. The rocket's not doing that. That horizontal movement that you see on the left to right, kind of like space that you see on the graph, is representing time. It's not the object moving through space. The object's moving up, it drops, the parachute opens, and then it goes more slowly. That's what the graph is modeling, all right? It's not, the rocket's not doing that. It's not modeling the graph, that's time. It's a really tricky concept. And it's something that I always have to remind myself of too. It's sort of tricky. Okay, suppose you start to swing yourself on a swing. That's fun. You move back and forth and swing higher in the air, then you slowly swing to a stop. Sketch a graph that could represent how your height from the ground might change over time. Use the scribble feature in Draw to create the graph. Label each axis with a variable using a text box to draw. To start, click on the drawing below. Okay, so I think tools are in. Okay, I don't know off the top of my head where the draw feature is. I think it's here, adding most, just no, insert. It might be under drawing. You can Google that, or you can ask me to look at it. I'm just going to use the zoom feature for now. that could represent how your height from the ground might change over time. Okay, so if I'm on a swing, I jump up on the swing and I'm here. I swing up, I come back down, right? It doesn't matter that I swung forward or backwards. It's just modeling height on that vertical. I swing up, I come back down because I made it a little bit higher this time. Swing up, I come back down. I swing up, I come back down. I swing up, I come back down. I swing up as high as I can, and then I jump off the thing and I plummet to the ground. Notice I didn't do this. This would be modeling vertical and horizontal space, where I want to model vertical and horizontal time. Okay, so this one on here is kind of what your graph should look like. And remembering, all I'm modeling is someone on a swing, but the graph looks very different than what the person's actually doing in space, or what the rocket's actually doing in space. Oh, thank goodness we're done. I'm a little over it today, but tomorrow's about another day. It's gonna be fine. Everything's gonna be great. I'm pulling up the quiz. Oh, but you can see. So what do I want from you right now? So finish that worksheet, do the practice, do the discussion, do the quiz, and then let's talk. So have you done it all? Pause it if you haven't. Come back to me. Okay, here we go. We're gonna do the quiz. It's only 2 problems. Great. The graph below shows the height of a hot air balloon during a trip. Name the variables and describe how they are related at various points on the graph. Okay, so there's a long way of doing this in a shorter way. So I'm gonna do the shorter way. So the horizontal variable is time. Vertical variable is height of the hot air balloon. We all see that, right? On the left it says height, on the up and down it says height, on the left and right it says time. How they are related at various points on the graph. So at the beginning, time is 0 and the balloon has not left the ground. It goes up pretty quickly and then stays at a set height for a while. Eventually, it slowly descends. Descends means falls, but slowly to the ground. How do you like me now? Again, this balloon is not traveling across space. It's not, the balloon is not, the balloon is not going up, 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 down, 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 down. This is not what the balloon is doing. The balloon is going up, 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 up. It's hanging out up here for a minute. And then it's very slowly going down. The balloon is moving perfectly vertically. It might be moving horizontally. There might be horizontal movement on the balloon, but that's certainly not what the graph is measuring. Okay. I'm kind of making emphasizing this point a lot because this is actually really applicable mathematics. If you start to notice, if you're watching the news, if you're reading an article, oftentimes if there's data involved, it will be represented graphically. No, I know this stuff pretty well, and I see mistakes all the time, all the time. axes that are mislabeled, data that's presented in a misleading way. And if you really kind of narrow in and look at it, you're like, that's not true. So understanding this math is actually going to help you function in this crazy world that we live in. Right, the table below shows the number of people in attendance at a drama club after 1, 2, 3, and 4 weeks. Sketch a graph that could represent the data. Okay. So I'm going to think of these as ordered pairs or points. So week one, we're at 4. Week 2, we're at 9. Week 3, we're at 15. Now week 4, we're at 33. I am now going to label my axes. This horizontal, I'm going to call it weeks. And this vertical, I'm going to call it number in attendance. Okay, go over. Okay. And then I'm going to sketch the graph. So I'm going, yeah, I'll just for the sake of reference, here's our origin, 1 over 4 up, 1, 2, 3, 4. There's my first point. My second point is 2, 9. There's 4, 5, 6, 7, 8, 9. Here's 3, 15, 10, 11, 12, 13, 14, 15. And week 4, 33. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 1, 2, 3, 33. Gaga. All right. So there's my points, and then I'm just going to connect the dots. I'm going to start at my order. Well, I wouldn't even really start at my origin because week 0 doesn't really make sense. It's not really going up from 0. It's starting at week 1. Boom. Boom. Something like that. If you were to plug these ordered pairs just like this into MathWay or Desmos, it would absolutely generate this graph for you. Okay, and we can look at that a little bit more later on. But for now, I'm calling it. I'm done. I don't care what you say. I will see you tomorrow, or I might not do it tomorrow, but I'll certainly do one on Friday for module 4, lesson 2. Thank you for putting up with me today. I know it was grumpy. I'll see you later. Bye.